Hey guys, today we're going to be looking at how different lines show up when you solve them graphically, when you solve them using elimination as well. So you can figure out what type of line you have based on your answer. So we're going to start off with this top part of your sheet. So if you follow along, you can fill out the top part of your sheet right there as we go. We're going to be looking at the three different type of systems that we're going to be encountering. The first one is what we've been working with, where we have two intersecting lines. When you have intersecting lines, they have one solution, and that's where they intersect. And the slopes of these two different lines are going to be different. Then next we have parallel lines. For two parallel lines, a sketch of a graph are going to be two lines that are parallel to each other. And those two lines, they will have zero solution since they're never going to cross, and their slopes would be equal in order for them to be parallel. Finally, we have a third kind, which is where they make one line. So if I have a line and then my other equation in my system is the exact same line, these are called coincident lines. And these types of lines, there are infinite solutions. And we just know that every single point on these lines is a possible solution, and the slopes would have to be equal in order for these to be the same line. So looking at that first system there, I solved them all and put them into y equals mx plus b. Sorry, this one at the bottom got kind of long. And then after I solved them each for that, I noticed that the slopes were the same. They were both negative 1/4. But then I had two different y-intercepts. When I have two different y-intercepts, I know that they are not going to be the same line, and I know that they're going to then be parallel. So these ones would be letter C. For letter C, they have the same slope if they're parallel. So if you have parallel lines, so parallel lines, they're going to have the same slope, and they're going to have different y-intercepts, and there's going to be no solution because we don't have an intersection. For our next system, the 4x plus 2y equals 8, y plus 2x equals 4. For this one, we're going to set them up into our slope-intercept form, and we would get y equals negative 2x plus 4, and then we get y equals negative 2x, excuse me, that's an equals, plus 4. And these two clearly have the same slope. They have the same y-intercept, so they are truly the same line. So we call these coincidental. And so if they're the same line, we say they are coincidental, and they have the same slope, same y-intercept, and they have infinite solutions. For our last system here, this third one, I solved them both into y equals mx plus b form. And when you look at these two, you'll notice that both of them have different slopes. We have the slope of 1/4 here and the slope of negative 1/4 there. And so I have a positive and a negative slope. And then I have two different y-intercepts, so I know that this one has to be my one that has the intersecting line. So if it intersects, we know that we have different slopes and we have different y-intercepts, and one intersection means that we have one solution. All right, for this example, you'll notice that this is one of the problems that we solved just above. This was the third one in the set we just did. And I just want to show you what you'll find if you're using elimination, what your answer would look like. So this one, when we solve it for using elimination, I multiplied my second equation by negative 2. And when I multiplied by negative 2, we ended up with y equaling negative 1. Then I subbed in y equals negative 1 to one of my equations, and I found that x equals negative 3. Because of this, we have a point. So x is -3 and y is -1. So this tells me at that point, -3, -1, these two equations, this system is going to have a solution. It's going to have an intersection. So that's why letter B, the graph above, worked for this one. So when you find that you have a solution in x, y values for your system, then you know that it is a system where they are intersecting lines. All right, for this next example, this was the first one that you had solved up above. And for this one, remember, we had found that they had the same slope and different y-intercepts. And so we found that there was no intersection or no solution. I want to show you what it looks like if you're using elimination. So for both of these, I set them up so my y's and x's were lined up. Then I multiplied my first equation by 2 in order to set them up for easy I could sub in and eliminate my coefficients and my variables. So then when we subtracted, we ended up with 0 equals -56. Well, that is a false statement. 0 does not equal -56. It doesn't today and it won't tomorrow. So if we have a false statement, that means that there are no solutions. And the only type of graph where we have no solutions when there's a system are parallel. So if you end up getting a false statement, your variables are eliminated, you end up with a false statement, then you know that your lines must be parallel because there's no solutions. And then finally, we're looking at our equations here for this system. And I put them so that they are in our standard form, ax plus by equals c. And then for that second equation, I multiplied on both sides by -2. And that helped me line up all of my variables and my coefficients so that they ended up zeroing out. All my variables went away and we ended up with 0 equals 0. 0 equals 0, that is a true statement. And since it's a true statement and we've eliminated all variables, then we know that these lines are the same line. So they are coincident lines. And they have infinite solutions. So when the variable goes away, when you eliminate the variable and you end up with a true statement, you really have two lines that are the exact same line.